Okay. All right. Hello, everyone. Okay, so this is where we kind of left off on Monday. So we talked about some form of a detection happens. Then we enter the view change protocol. And the first step of the view change is to, well, these two are kind of related. The detection and the view change are somewhat related. But the moment you detect failure, let's say you have a timeout, meaning that you were waiting to get something from the client, or you were waiting to get something from the primary, or you haven't been getting anything. So you kind of stall. So in that case, you say, okay, I have detected failures, and then you send the view change. And the view change message basically says, anything that goes wrong, what do we do? Anything that goes wrong, irrespective of network or any other condition. What do we do as soon as something goes wrong? Meaning, we blame the primary. So that's important, because if something goes wrong, if you have too many moving parts, which one are you going to adjust? And whichever one you decide to adjust, you have to make sure everybody's agreed, so you all try to adjust the same thing. So in the distributed setting, one simplification is to just blame the primary. And that really simplifies it, because you don't have to now reach an agreement. How are we going to try to fix the configuration, or fix the setting that we're in, or fix the environment that we're in? Irrespective, maybe the primary is not even doing anything wrong. Maybe the network is bad. Irrespective, you just blame the primary. And the hope is, if you blame the primary enough times, eventually the primary will change, and eventually you will land on a primary that is non-faulty, and eventually the network is also non-faulty. And when all of those align, that's only when the protocol can make progress. Yes. What do you mean get information from the old primary? Why? I mean, if the old primary is faulty, how can you even get information from it? What was the whole point of commitment? What was the point of commitment? To make sure whatever is committed is being propagated enough in the network that can be preserved, meaning you don't need the primary. So there's enough redundancy, there's enough replication in the network that you can just change the primary. If there's agreement to change a primary, you can go ahead and change the primary. And what you send as part of your view change message, you essentially send your history. You say, these are all the things that I have done. These are all the requests that I have prepared. The most important one, this is all the requests that I have prepared. You can also include the requests you committed as sort of an optimization, but the necessity is include all the requests that I have prepared so far. And the new primary collects that. And the new primary needs to form a view change quorum. So that means, or a recovery quorum, meaning that enough replica have sent a view change message to it saying that you are the new primary. And then it will reconstruct or reassemble what the history should look like based on all the inputs that received from the older replica. And the history that it proposes is considered a new view. Is that kind of says, these are all the things, according to the information that I received, this is all the requests I were prepared. And that becomes the new view. And the support of the new view is all these view change messages. So, and it constructs a proof. This is the new view. And this is what was sent by the majority of the replica.
So the change message will prepare message, the replica collected. Once the new primary collected to F+1 prepare message, run all the
View change message. It collects 12+1 view change message, not prepare message.
yes, it will.
It can construct a valid history. And so basically, if only one thing happened, I was the old primary, you all send a message, and let's say he's the new primary, you all send a message to him, and you say you prepare T1. And if he collects enough quorum saying that he's the next primary, and if he observes that even at least 1% said T1 was prepared, then he can propose this new view. In the previous round or in the previous view, one thing happened, and that was transaction T1. So the new view, so then we also talked about we have two things we wanted to. One, we want a view synchronization. One is a state synchronization. View synchronization means we all synchronize, we all agree who the next primary is. The majority agree, or the majority move to a new view together. That's the view synchronization. And the other one is the state synchronization. State synchronization means we synchronize our states to make sure that we are all on the same page, meaning we able together determine what could have been committed and we're able to preserve it. So we have view synchronization, and then we have a state synchronization. During the commitment, the normal flow of the protocol, when you prepare and commit something, you're essentially doing state synchronization. You're synchronizing your state. You're synchronizing the next transaction that was going to be added to the ledger. So everybody becomes synchronized, so the majority becomes synchronized. Does that make sense? So during commitment, we only do state synchronization. During the recovery, well, we have to do state synchronization of the past, not the future. And also, we need to do view synchronization. The view synchronization is I agree who the next primary is, or I agree that we are all now together move to the new view. I'm just going to pause, let that sync, see if any questions on that. So why do we need state synchronization? What's the need for state synchronization? Yeah, so we can all agree on what the past state is. For example, if she was in dark and this new primary could help her to also become up to date. So that's the state synchronization. Why do we have to do view synchronization? And why do we have to know that? What happens if you don't synchronize that? Could we ever result in an inconsistent state? Is it possible that we end up preparing upon the change of the primary? Is it ever possible not to construct a conflicting core? What did we say about prepare quorum? Prepare quorum is unique. So the problem is if you're not careful, some people think he's the next leader, some people kind of wait for him, some people think he's the next leader, and some think he's the next leader, and we all kind of spread ourselves among a bunch of primaries, potential primaries. And now either of them propose something, none of them can collect enough votes. So then what happens is that we're never gonna be able to commit anything because we're gonna spread ourselves across so many potential primary. So it's important that we all agree that he's the next leader. And if he's not responding, then we all need to agree that he didn't respond, and he's the next leader. And then if we need to get some form of an agreement that he's not responding, then go to her, and then maybe hopefully she start responding. So the view synchronization is also important. So which of these transactions help us, you think, with the view synchronization? Which one do you think help us with the state synchronization? Which of those messages? Why?
Because when we're reaching the change state,
Because the new primary would only send a new view once it's hears from 12 plus 1. So that means there is an agreement 12 plus 1 thinks is the next primary. So the view changes help up with the view synchronization. New view is about state synchronization. The new primary tell us what happened previously. Help us to synchronize. Questions? Any questions? All clear? Okay. All right. Most of this we've covered. So maybe this one, the other one was, so let's kind of start here. So when is it that we're gonna start a view change? Is that once we detect a failure. So for example, he may detect a failure, you may detect a failure, and then you send a view change. So currently I'm the first primary, I'm the current primary. You detect failure in the sense that you've been waiting to get a prepare or getting a commit, you're not getting it. So you time out. You also time out. You send the view change message to him. He's the next in line. You send the view change message to him. What is he gonna do?
plus 1, and like we change message.
Why?
Because might just be like 1, then another is gone wrong.
Because both of them could be lying. Because if, for example, the threshold F is, I don't know, in this room is 5, they're less than F. So the two of them could even be lying. So he's going to ignore it. So what are the possibility? For example, you prepare something, you never get commitment, that could be a potential failure. Or it could also be the case that you haven't failed yet, but you get view change message, and usually view change message is sent to everyone, including the primary. So you had timed out, he had timed out, she had timed out, and enough people sort of send view change messages. Let's say F plus 1 view change messages was sent to everyone. The new primary received F plus 1 view change messages, but it's still not sufficient. It's not a quorum. So it's still not taking an action. However, if it's a non-faulty replica, it sees that there is at least one non-faulty replica that is saying something is wrong because he's received F plus 1 view change message. So any non-faulty replica that observes an honest replica have failed, he also joined the view change. He sent the view change message directing it to himself. Let's change. And anybody else in the room who's non-faulty, now they trigger. So now that helps to collect 12 plus 1 view change message. Yes.
All these are one more keeping target.
Say that again.
Have polynomials and one keeping target. The one those keeping target.
Well, the one in the NARC could also be timing out because the node in dark technically are not making progress. They're in dark, they're stalled. So they will probably send a view change message, but it's possible that the nodes are in dark, they are partitioned, so their messages are not going across. Yes.
Looks like a specific node that you would consider. Like,
It doesn't know, but if you receive f+1 view change messages, that tells you f+1 replica have are timing out, f+1 are experiencing problem. You know f of them could be lying, but at least one of them is telling the truth. And as soon as you observe there is good honest replica that it says something is wrong, then you also raise flag. And it is possible that f+1 non-faulty replica are raising a flag saying something is wrong. But as you said, F good replica are in dark or are partitioned. They're not accessible. So they're not making any progress. F+1 replica are saying something is wrong. The F malicious one, they're not going to participate. They're not going to say anything. So now the whole system is stalled. So the only way that we will get into things could recover is that those F nodes that are partitioned out, once the network is restored, eventually their view change messages will come out. And now we have finally 2F+1 view change message, and only then the next primary can work on the recovery. Questions? Yes.
you have like balance, you have +1 will change message. It's going to know that this one is like honest, right? So is that because you like only allow like tolerance, like that faulty tolerance?
You could have F malicious, not F tolerance. Everybody could fail. That's fine. We're not going to make progress. But as long as we don't have more than F who are malicious, meaning that they will send conflicting stuff. If you have more than F that sends conflicting stuff, then things will break.
Like what happened with that?
Well, the system has no guarantee it's going to produce wrong results. That's the premise. So it's an assumption. Assumption is that I run a system, I pick the value, there are at most 5 malicious one. If that assumption violated, everything falls apart.
Like more than that issues.
It's a difficult problem. It's an interesting research problem.
Delay estimate is right.
You don't. So that's a good one. So for example, you think, for example, you could, ping some people in the room and figure out the ping latency is about 1 second. And then says, okay, I'm going to put a network delay of 2 seconds. So I expect within 2 seconds, messages that are sent to me should arrive. And so your timeout now is going to be 2 seconds. It's just an estimate. And everybody could have end up a different timeout estimate. And as soon as my timeout goes off, my timer goes off saying that I was expecting to receive something based on the network estimate, the delay estimate, then I go into the view change. And then I go through all this view change process. But then when I go through the view change process, I also increase my timeout. So exponentially increases. So if it used to be 2 seconds, after one view change, I make it 4 seconds. After another view change, I make it 8 seconds and 16 seconds and so forth. And the reason we exponentially increase it is because the reason that I don't see any progress, maybe my timeout was wrong. So again, if enough failure happens, enough view change happens, then I keep increasing my timeout. And eventually everybody will have a sufficiently long timeout period in order to allow one round of consensus to happen. So yeah, that's important. I mean, it starts with an estimate, but you can adjust that estimate.
Like would you have 1 second just like
You could observe things, see the consensus is happening very fast, you're going on for a while and things are moving fast, and you could just bring it down. But then you could go back to the view change. So for example, you put it for 16 seconds, but then you realize the consensus is happening in half a second. So definitely the message back and forth is sub-second. So you could reduce your timeout now to 1 second or half a second. And then that may operate for a while and things are functioning well, and all of a sudden there is fluctuation in network, and all of a sudden delays start to happening, and then you won't be able to get messages fast enough. It's in your timeout. You go to view change. Once you go to view change, now you increase your timeout. Make sense? The other thing that you could also detect a failure is that if a client sends something to the primary and the primary doesn't propose it, it could send that request to everyone. And then everyone will forward that request to the primary saying that you got to make sure you increase, you propose this, and they put another timer on it. And if the primary doesn't propose that client transaction within that timeout period, they would also do a view change. Why do you think that's necessary? Why do you think we would need this mechanism? But why, under what circumstances the client will send it to everybody? Or the primary is malicious. If the primary, because primaries could essentially censor certain transaction or ignore certain transaction. But if the client just tells us, oh, the primary is malicious, we don't know. Maybe client is lying. Maybe client never sent a transaction to primary. So we don't know whether client is telling the truth or the primary is telling the truth. However, the moment the client sends us the transaction and we all send the transaction to the primary, now that we know that we personally send the transaction to the primary, now the primary needs to propose it within some timeout period. And if it doesn't, now we can blame the primary. So that's usually the more typical way of detection of potential fault. Either to every single replica or at least majority. Because for it to work, you really need at least F+1 good replica telling the primary, because then they could potentially construct a view change quorum if they don't hear anything back. So, and you may just send it to everybody. I mean, default is just to send it to everyone. Yeah, so that's what I mean. So if it's forwarded a client request to the primary, then it's expected to commit within certain time or gets proposed within certain time. That's what it means. The exact scenario that I described now. So you're the client, you send me a transaction, you send the transaction to all of us, we forward a transaction to the primary, and we expect that primary to commit that transaction within the next 10 seconds. And if he doesn't, we're going to blame him saying he did something wrong. Or could have just said expect proposing it. That's also same. Questions? Okay. So this one is, I had a figure. Let me see if the figure is in this slide. Let me see. Yeah, I think this is good. Yeah. So now, one thing we kind of haven't really talked about, and I think this is probably the most important aspect of all this consensus protocol, and it goes down into the failure detection and as part of the view synchronization. I think the state synchronization or commitment is pretty straightforward. You essentially prepare, commit, you ensure the uniqueness, you ensure preservation, and that's it. But the view synchronization is a little bit more trickier. First of all, as it was said, it's possible that not everybody have the same timeout. If somebody thinks it takes half a second, another person thinks 2 seconds, but the actual request takes 2.5 seconds, it requires some time for everybody timer to sort of adjust in such a way that is large enough for something to be able to make progress. So that means potentially a sequence of a view change will happen. We keep blaming primary, double our timer, blaming primary, double our timer, blaming primary, double our timer, blaming primary, double our timer. And eventually our timer will be large enough for progress to take place. So, but now, so that's a high level. So now in general, you could see that you could have R3 detect a failure, tells everybody, and this is the old primary, this is the new primary, R3 detects a failure, tells everyone. Some later time, R1 also detects a failure and just notifies everyone. At this point, what we have is that R2 have received what? 2 failure message. These are actually the view change message itself. These failure messages are essentially the view change messages. So at this point, R2 has received 2, F+1. So that means it knows that at least one of R1 and R3 are telling the truth. Same as the leader. The leader has also received 2 failure messages. This one is also received 2 failure messages. So they both have received F+1 failure messages. And the moment they receive F+1 failure messages, they also broadcast their own view change message. And at this point, we're getting synchronization among the majority. Meaning the majority now agree is the next primary. So it could start with someone, others join, then people who haven't actually themselves detect a failure, they detect at least one non-faulty replica have failed. They send now their view change message or their failure, and eventually we get a quorum, 2F+1 view change messages or 2F+1 failure messages, and the new primary can now construct a recovery quorum and take everyone into the new view.
Failure stage is simply must done. Yes, becomes a
Say that again.
failure stage is P with +1 or
So that means just make sure detect means, I mean, all of them are just failure messages. Detect means I got timed out. Claim means enough people have sent me that they failed and I collected enough messages to make sure this is a valid claim because there's F+1. And so once I be able to, so I can either detect a failure myself or I can detect or I can observe a valid claim of failure when they're coming from F+1. Then I will also join the effort saying there is failure, or I'll send a view change message.
so what is a
So this was the original one, and they all kind of we kind of go into deterministic. So I'm the first primary. This is known. So I'm ID1. I'm set a replica ID1, replica ID2, 3, 4, 5, 6, 7, and so forth. I'm the first primary. Then he becomes the second, then third, fourth, go around again. I be a primary, then he becomes primary, and we kind of keep going around because the reason that maybe when I was a primary, the reason you all switched over because the network was bad. So you can't really say just even though we blame the leader, doesn't mean that the leader was actually faulty. So we keep kind of going in circle. 1, 2, 3, 4, 5, 6, round robin, and again 1, 2, 3, 4, 5, 6. Just keep going in loop. Actually, let me ask some other interesting scenarios. So this is a kind of a happy case of a synchronization. It's a happy case because some were able to detect failure, others were able to observe a valid claim of failure, and they all sent it, and we were able to synchronize, meaning the new primary was able to collect 2f+1 failure messages or 2f+1 view change messages, and now is able to do state synchronization by sending a new view. So now the question is, what if we don't get 2f+1 view change message? What do we do then? Roll back to what? We're saying there is a failure. So this is detect. So these two have detected failure, let's say. These two have timed out. They have sent their view change messages. But imagine, let's say, imagine these messages are not arriving. They're not arriving. So what do? These two, R1 and R3. R1, these are honest replica. They know they've timed out. They know they haven't, for whatever reason, they timed out. And they're honest, so this is a honest timeout. And so they're sending a view change message. And they're all saying V+1 or V+1 is the next primary. They send it, and imagine that the V+1, in fact, maybe received them, let's say. But it still hasn't collected 2f+1. So is not able to collect a core. What do we do?
Wait for failure detection message
To whom?
to everyone.
But sending it, so, well, what if these messages are being ignored by this primary? So this is one case, is that they're sending the messages and they're not hearing anything from it. Or maybe others have sent messages to the primary too, and still nothing from the primary. So how do we distinguish between those two cases? So we send a message. So now we have to decide, when I send a message, is the next primary faulty or it's not faulty? When is it the time that I say, well, you know what, he's not going to help us to move on. I'll go to the next, then go to the next, go to the next. And this was the initial problem that I mentioned, is that if we're not careful with this synchronization, we could everybody may think somebody else, a different person is the primary. And we're just going to spread ourselves thin across many possible candidates. So how do we deal with this? One thing is certain so far we know. When is it that a non-faulty primary can send a new view? When is enough people are synchronized? So this is a happy case. So what if either the primary did receive 12+1, but didn't act, or maybe primary didn't even receive 12+1. And again, remember, we're doing a broadcast. All of these messages all to all. So I send my messages to everyone. Everybody sends it to everyone. So what should we do? When is it that we can say the primary is no good to move on? The next primary. Well, the current primary we know it's not good. We're saying, when can we give up on V+1 and go to R1 and go to R2 and then R3? When these two have already said this is failed. So, and you don't go back. So once you detect a failure, you raise your flag, you don't go back. Now, when is it that we can give up on PV+1? Add your hand up. Now,
we know we claimed failures or we've got 12 plus 1 failure messages?
no. So saying who got 12+1 failure message? How do you know everybody got 12+1?
Because the failure detection is broadcasted, so everyone gets the same.
No. Again, remember, messages could be dropped. You don't know. You can only, it's like saying that I prepared, everybody else got also prepared. We're kind of going back to the same rabbit hole. So you could count your messages that you received, but whether everybody else have the same count as you don't know. It's a distributed system.
Yes, like, there's certain amount of time you don't receive a message. And you can send out your own.
Well, so that's the problem, is maybe King or everybody else maybe got it, you didn't get it, but now you moved on. And different people now, they move at different time. So just because you haven't received enough, if you were to just say, oh, you know what, I'm gonna go to the next one, you don't know, maybe different people are waiting different time and so forth. So
But we can receive 2 as plus 1 will change and then didn't receive the new wave from the new triple rate. Tell others that we should move to the next triple rate. And if the similarly those receive as one new will change, they will also say we should move to the next.
okay, that's a good, interesting thought. Let's move on. Let's keep that. You had your hands up too.
I was thinking, like, your example, the POA plus 1 is not responding.
Well, whether it's responding or whether I'm not getting it is possible. Maybe it even sends the new view. I just didn't receive the new view.
So imagine I'm R1 and I'm sending the.
So you're R1, you detected failure, and then what?
In this case, I'm sending different failure to all the other replicas.
Yes.
With that one, didn't see it or didn't receive it or ignored it, but the other replicas still receive it.
How do you know they received it?
Like if I receive it, I'm just lost. If they receive it.
But how do you know they received it or not?
If I got the reply, like the R2.
Okay, so first of all, there's no reply here. There's no acknowledgement. Everybody just sending a view change message. So there's no acknowledgement. When I'm sending a message, you're not acting. Exactly same thing we did with prepare stuff. When you send your prepare message to everybody, you may collect 12+1 prepare message and you get to the prepare state. That doesn't mean that she's in the prepare state. So it's the exact same. So you have to think in exact same way. The fact that you got prepared doesn't mean she got prepared. That's why we had, for example, that extra phase for the commitment. Thoughts? What happened if I don't get anything from people from it? Okay, let's think about it more. Sure.
What if you decide that they didn't respond? What if they're just taking too long to respond?
How do you know that? How do you tell the difference? That's the question. That's just a rephrasing of the same question. But that's important. That's the key. How do you know? That's the key. No, there's no threshold. I mean, I don't know. Threshold means maybe means many different things. So I'm not sure what threshold you're referring to. Are you saying that maybe?
The time threshold.
Because even if there's a threshold, how do you know that he has the same threshold as you? How do you know you both started this, even if your threshold is the same, how do you know that you both started at the same time? The clock. Clocks. You could ask a question too, so it doesn't even have to always answer. You can ask a question. So usually when you ask questions, it helps you to kind of get one step closer to the answer. Questions or answers are together always, yes.
Okay, so you mentioned, I think in the previous slide, like a timer, and basically every time it's each.
Well, I said there's a timer to detect failure. So I detect failure. Then I send the view change. I detect failure. No, you still have time. You can't escape. I have so you still have 5 minutes. So I have 5 minutes. So I detect failure. Now I send it. Now I've detected failure. I've asked the next guy in line to take over. Nothing happens. What do I do? Do I keep waiting? Do I go to the next person? What do I do? If all goes well and everybody receives get to the synchronization point, then it's a happy case. But what if it's not the happy case? Yes.
So, like at this point, is there like some primary out there?
Well, at the point of a detection of these two, this was the current primary. This is the next primary in line. And you can assume when this was the primary, everybody knew that this is the next primary. As I said, first means you're kind of going enumerate. So everybody, when they send the view change or the failure, they said who they think the next primary should be. So they state that.
But like R1 and R3, they need to get some message to know that like it's not gonna work. So that like we cannot even have the timer to play or something.
Message from whom? What message?
So what I'm trying to say, like the message from some primary or
No. You have one failed primary and you have a candidate. You don't have a primary. You don't have an active primary. But this one is say, as far as these two concerned, this is failed. They blamed it. We're not going to trust it. There's one candidate. There's a candidate right now. But this is a candidate. It's not established. And you can't just say, I have an oracle. Because what you just said basically said somebody tells you what to do. That means there's an oracle. You're now trusting on there's a central thing that can tell you, help you to decide who the next primary is. That reduces to an oracle.
like seem to get some kind of message.
Some kind of a message, but not from an entity that a trusted, reliable entity.
So like when you get when like from our perspective, explain failure.
Yeah, so this one is actually detected. He detected himself.
He detected once, and the next thing on, he also got on once, failure message, so now he thinks, from his perspective, that he should be receiving a synchronized message in the certain time. Plus one, the new primary, but he doesn't get that, so he gets all not just.
Failure on
all
plan. So then try to make this one a primary. So then, but at this point, if it does that,
At that point, you're supposed to wait, so let's say we go to wait some point in time.
yeah, so at this point, it puts a timer, whatever timer it puts, and it waits for this one to respond. And if it doesn't, it goes to another primary. But it might be that, imagine this point, imagine this line that goes to R1. Imagine this line is here. Just an example, it's here. Now at this point, this one will set a timer, so it switches to the next one at a different time. So now we could potentially start changing primary in not a synchronized way. And it's possible that the rest actually saw this as a primary. They all got, everybody else got these messages. So let's say R2 got all of it. And R2 So this is as a sort of maybe a valid primary and kind of now waiting for it. It even R2 got synchronized.
So then what happens if like the Apache detects the failure, but no one else detects failure? So only Apache is the sole person that hasn't met the sort of +1 threshold for everyone to claim failure. Then does R3 still thinks that PB is the primary, or is R3's PB +1 to be primary?
That's a good question. That's something you go back and start building on that. So he also said something that was actually was on the doc. I don't know if he remembers it himself or not. You. That's what I said. So think about it. But these are that's the right question. The question you asked, those are good questions. So that could potentially help you to answer. All right, let's continue this on Monday. Well, of course, we're gonna have our quiz on Friday. Friday is a holiday? Monday is a holiday? Okay, so Wednesday. I didn't know it's a holiday.
It's origin and it's a view change message.
Yeah, these are all view change messages. Both the pink, all of these are view change.
And for this part, why R3 and R1 is not sending out those orange messages?
These are the same because they all send their view change. These ones collected enough view change messages, so now they're sending their own view change.
Okay.
So these, I mean, essentially all of them should be the same color. All of them are pink. But this one is not that they detected, they didn't, it's not that they're sending a view change because they timed out. They're sending a view change message because they observe at least one non-faulty replica has timed out. So they're joining the effort of the view change by sending their own view change messages.